Hi, and welcome to this video where I'm going to show you how to take a dataset of a CSV file which contains a dataset of the motion that was recorded by moving video game controllers in three-dimensional space. And then I'm going to show you how to parse all this data, bring it into a 3D modeling environment like Rhino and Grasshopper in this case, and write C# scripts to take all this data, parse it, and then turn it into three-dimensional planes that we can use to visualize this data and then to perhaps manipulate it and create some kind of like nice visualization of this motion, which is what I will do in the next video of this series. I want to first show you how this is coming from an assignment that I gave my students in the Introduction to Computational class that I teach, Introduction to Computational Design class that I teach at Harvard University. And what you can see is that they were using HTC motion controllers and they were moving in three-dimensional space and they were saving that data in order to create visualizations of that motion. So what that data looks like is something like this. It's basically a CSV file that contains columns for, first of all, for the timestamp at which that was recorded, and then X, Y, Z values of the center of one controller, X, Y, Z values for the X-axis of one controller, so the main direction, X, Y, Z values for the Y-axis, so the secondary direction, and then a bunch of other metadata as, for example, whether if the user was pressing the trigger or not, and values for the touchpad. So these controllers have this touchpad button that you can move your finger around, and then it gives you the value of like how far off in the touchpad these values are, the finger is. So I have these files here in my system as motion 1 and motion 2. You've seen them open in Excel, and then here this is a representation, for example, if you just open the CSV file in a plain text editor. So it's just like a header that tells you what each column means, and then a bunch of numbers and true and falses representing the values for each one of the readings of the motion controller at each, I don't know if it was like 30 times per second or 15 seconds per second. I actually don't know about that. We can read that from the timestamp actually. And what I'm going to do is I'm going to use Rhino and Grasshopper to parse the CSV file from my system, take all the data, construct geometrical objects such as planes, and then visualize them here in Grasshopper. That's going to be the scope of this video. I want to mention though that the full data set of recordings of the motion that we did for that class last year was open source and was publicly available. It's here under github.com/gsd6338, which is the name of the class. And if you go to fall 2019, you can go to assignment 0 and you can download a zip file with all the recordings of all the students. I have chosen a couple of them, and I have them here in my system now, and those are the ones that I'm going to be using to read into Grasshopper. I also want to mention, I don't know where you're coming from, but this is the last video on a series of videos where I explain how to read CSV files from C#, from any C# environment. So I actually recorded previous videos where I showed how to read CSV files from vanilla C# inside of Visual Studio, and I showed how to also do it in a more clean way, which is taking that data and turning it into native objects or classes. Okay, so I'm not going to be explaining that. You should have watched those videos before here, so I'm going to assume in this video that we already know how to parse a CSV file, and then I'm going to cut straight to the chase and taking this file, parse it real quick, and turn it into geometry objects that we will be using as the base of our motion visualization in my next exercise video, in the next algorithmic modeling video. Okay, so shall we start? Okay, so let's start by the beginning. What you can see is that I have here a Grasshopper file where I have written in 2 different panels the paths in my system to where I can find the files. So these are motion 1 and motion 2, but you're welcome to go to the GitHub repo, download the file, and use whichever files you're interested in using there. Okay, so I'm pointing to where in my system those files are. I have created a C# component that takes one input, and you have to remember to set the type of the input to the string. So this is going to be the path where the component needs to find this CSV file. Okay, And then I also created an output for this component, which is going to be the planes of the first controller. Remember that in this particular file, I was recording two controllers at the same time. So I'm going to start working with generating the planes for one of the controllers, and then by the end of this video, I may actually do the both controllers or whatever. I don't know. And then if I double click here, you can see that I've already entered some data, some code. So for example, I am reading the contents of that file that is coming in by using the system file read_lines function and taking the CSV path that is coming into the component as an input. And then here in I'm writing a for loop where I am going over all the lines in that CSV file, so all the lines in the string of text, and starting from the second one because I want to skip the header, that is not real data, okay? And then I'm taking that line of code, that line of data, I'm splitting it with the comma characters, and I'm storing that in an array of strings, which represents the data for each one of the rows. So maybe this should be called row data a bit more precisely, okay? So all of this was explained in my previous videos, so I think I'm going to start here now, and I'm going to start parsing the data of my CSV file into Rhino and Grasshopper objects that I can use to represent on the screen. And the first thing that I'm going to do is I'm going to take all the centers of the planes of my first controller, and I'm going to create them as points, and I'm going to plot them on the screen. If we look back at the CSV file, I'm going to be using Excel, even though I already explained that this is basically a plain text file, but I think it's a bit easier to read the columns in Excel than it is in this data file here, in this text file. So you can see that if we move to the left, the first column is the timestamp, which we will want to parse at some point, but you can see that the first, the second, and the third columns are the X, Y, Z coordinates of the origin of motion controller T0 of the first one. So what I'm going to do is I'm going to say, well, let me parse the first three columns, 1, 2, and 3, parse them into numbers, and then create a point with those numbers, store that point in a list, and then that's what I spit out as part of the component. So let me create here a list of origins, for example, and this is going to be a new list of point 3D objects, okay? And that's going to start as empty. And then what I'm going to do is I'm going to say, first of all, I'm going to create a variable called x, for example, which is going to be the conversion to double, where is double, to double of the data, row data, which is present at column 1, so the second column, right? So that's going to be this, and then I could do the same for y and for z, and then I could use 2 and 3. Okay, and with that, I could create a point 3D origin 0 of origin of the first controller, which is going to be a new point 3D object with the x, y, and z coordinates that I just parsed from the CSV file. Now, to origins, I'm going to add this new point that I created, origin 0, okay? And I'm going to run this code to see if I have any errors. So I'm going to run it. It looks like everything is fine, but I'm not seeing anything on the screen. That's because I am not outputting anything from this component. So temporarily, you know, I said that the output was going to be T0, the planes, but temporarily, instead of planes, I'm just going to spit out these origins. So just to make sure that that this is working okay, so I'm going to say the planes that I want to output for the time being, I'm going to be outputting just the origins. So I'm going to click this, it works, this changed to data, and I can see that, oh, I have a blob of stuff here. Oh, look at this stuff. How beautiful is this, huh? So it looks like I do have some kind of notion of motions. I have like a list of ordered points in three-dimensional space. And just to make sure, let me visualize those with like a NURBS curve. So for example, let me interpolate a NURBS curve through all these vertices and see what that looks like. And I can see that indeed they are, they're very ordered, you know. So I have been able to generate, for example, a curve in 3 dimensions with the inputs of the first controller of the motion. I think this is already kind of cool, right? So I could record the motion of that controller, and now I can plot it in three-dimensional space, and I could do a lot of things. I can, for example, I can pipe this, right? I can create a tube around this curve. Maybe this cube is going to be very dense because there's so many points. I'm going to crash my Grasshopper. Yes, so the radius was way too much. So for example, let's say we do 0.05, okay? And then you see, I was able to now generate this kind of pipe geometry along that trajectory of the motion that I have recorded. I find it amazing. I don't know what you guys think, but I find it amazing that from this crazy list of unfathomable numbers, turns out that I have like a really nice hand trajectory in this recording. Okay. Okay, but let's not stop there, because if you remember, the motion controller not only has location in three-dimensional space, it also has orientation. So the people who were recording were moving their hand and were doing this kind of motion, which is also information that is present in the dataset and could be super interesting for visualization. So let's bring that in as part of the plane. Okay. So what I'm going to do now is I'm going to say, well, I'm going to go back here and I'm going to start adding more data to this. I'm going to parse more data from the CSV. So you can see from the CSV that I have other columns here, x-axis x, y, and z. So I have the x, y, z coordinates of the x-axis of the orientation of the controller, and I have x, y, z for the y-axis, so the secondary axis of the orientation of the controller. With the point that I've already parsed, and with the main vector and with the second vector, I will be able to create a three-dimensional plane that represents the orientation of the player while they were moving their hand in three-dimensional space. So let me parse these 6 columns into 2 vectors and then create a plane that is using those two vectors and that origin. So let me say, for example, I'm going to say I'm going to reuse these variables here because I've already used them to create the points, so I can actually reuse them. That is not great practice, but I'm kind of hungry and I want to go have lunch, so let's just reuse them for this one. Okay, so now let's take this, and then I'm going to remove here where I declare them, because you cannot declare them twice, and this is going to be 4, 5, and 6. And then here I'm going to say vector 3D x-axis is going to be a new vector 3D with x, y, and z. Okay, so this is going to be the x-axis. This is going to be the origin. Okay, and this is going to be, now I'm going to copy paste all of this again because I'm going to reuse the x, y variables. This is going to be the y-axis. So now this is going to be 7, 8, and 9. Those are the positions of the columns in the table. And now this is going to be y-axis. Okay? So now I have created, and I'm going now to remove this. I have been able to parse from my data set 3 objects: the origin, the x-axis, and the y-axis of the main controller. I can take that data and turn it into controller 0 plane by saying, let me create a plane object called PL0, for example, and that's going to be a new plane. And you can see that as I open parentheses, it gives me options about what can I input to create a new plane. And what I'm going to choose is to create a plane out of the origin, the x direction, and the y direction, which is what I have in my data set. So that's going to be origin 0, x-axis, and y-axis. Okay, and then controller 0 planes. I'm going to rename that list, and then I'm going to the list of controller 0 planes, I'm going to add this controller plane that I just created, and I'm going to plug that in here. Oh, and something went wrong. What did I do? Cannot convert Rhino geometry plane to Rhino geometry point 3D. Yes, because I forgot that when I created the list of controller 0 planes, the type that I specified here was point3D. So I need to change this to a plane object so that when I add that here, this can contain that data type. And as I do that, oh, it looks like everything is working. So if I turn this on, so I get this cloud of really crazy planes, but that's because I am representing them with a very big size, with 1 unit. So I'm going to, in my Grasshopper, I'm going to go to preview plane size, and I'm going to lower the size of these planes. And now you can see, if I rotate around, you can see that for each one of the points, I also have the orientation of that plane, which is kind of nice because I can see how in this cloud of motion, I can see how most of the planes were actually pointing out. So it looks like the user was doing this motion where they were pointing outwards of this motion with the hand, which I think is super interesting. And therefore, if I were to do, for example, let me just populate this with cones, right? So you could see, and this is probably like super large as well, but you can see how now if I reduce the length of these cones, and actually let me reduce this as well. Okay, so we can see now how by representing with cones, I can see where the controller was pointing at any given time. How cool is this? All right. So this is basically the core of taking this data set, parsing each one of the columns into information, and then using that information to represent it in a three-dimensional form in Grasshopper. Okay, so let me take a pause, because what I'm going to do is I'm going to now add more code for the other controller, and then I'm going to show you what this would look like finished. I don't think you need to see me typing that, but if you're interested in seeing me typing all of that code, just go to the live stream video where I recorded this video. Okay, so let me show you how that would look like when incorporated all of this data inside of the parser. Okay, and I think we're good. It took me a little bit of typing, but what you can see now is that for this file, for the CSV file, I have created many more outputs of things that I can parse from the CSV file. And if you remember, the CSV file not only had the coordinates of the plane, but it also had like information about what the user was pressing on the controllers, the trigger, if it was being pressed, if it was being clicked. Pressing is if the trigger is, because the trigger has a degree of value, whether if the trigger was being pressed at all, or whether if it was clicked, which was like it was pressed all the way in. And there was also the trigger value, because it's a scalar, so you can press like halfway through it, you know. And then here on the C# file, I have created more lists for things that can come from the controller. So the planes, whether if the trigger was pressed or clicked, and these are booleans in this case, and same information for the plane 1 and trigger and press. And then I have just copy pasted here information from the controller, and then I'm taking from each one of the rows 1, 2, 3, 4, or 5 in particular information for the origins and the vectors. I am creating this plane with all the information that I have parsed, and then to the list of Boolean values on whether if the trigger is pressed or not, I am adding the converted data to Boolean that I'm taking from the other columns that are relevant for this data. And then I have basically repeated the same process for controller 1. What you can see now is that I have 6 lists of data, one corresponding to the motion of one of the controllers, the other one corresponding to the motion of the other one, and you can see how very nicely they are very close to each other, which means that the user was probably moving the controllers in this kind of fashion. All right, and actually I can visualize that very easily by creating, for example, a line object that goes from one plane to the other. So what that does is that it creates lines between the centers of the planes, ignoring the orientation. And then you can see how exactly, indeed, this motion was very clearly the user just doing this motion with the two controllers, but by keeping them very close to each other. okay? Which gives me like a really nice visualization. And I could, for example, now loft a surface over this, or I could use, for example, when the trigger is pressed or click, I could use that as a way of knowing when I should plot that geometry or not, for example. And then I can do a lot of things with this information. It's a very nice data set now. So actually, what I'm going to do is that I'm going to stop the video here, because what I would like to do is now that we have all this data as planes and geometry objects, I would like to create another video, an algorithmic modeling video, where I'm just going to experiment with this data and see what different ways of visualizing this motion I can do given this data set that I have been able to parse from the CSV file. And I'm going to experiment that with a lot of files from the data set that I just pointed out to you. So if you're interested in that, please follow up. There probably will be a link to that video somewhere here popping up. And also, if you like this series of videos, also feel welcome to subscribe to the channel, to hit notifications, to like this video, and all these things that help us keep this rolling. Okay? Thank you very much, and see you on the next video.